In the previous video, we saw how can we fire our needle and detect the collision between our circle and the needle. So now we are going to rotate our circle. And for that, we need to go here in the scripts folder, and I've created circle scripts. So let me just add a space between circle and scripts. And here I have created circle rotate script. Simply double click it so Mountain Develop will open it. Here we need a couple of variables, and I'm going to create a serialized private float, which is going to be the rotation speed. So rotation speed, and let's say we set it at 50 at the beginning. And by setting it to be serialized field, it's the same thing as what I explained with our needle here when we used our rigid body. So I can attach our script on the circle, and here we have the rotation speed. So we can tweak the rotation speed here in the inspector panel, and that will be applied. So if we add here a new value, so let's say 60, then that value will be applied in the script for our rotation speed. Here I'm also going to create a private Boolean variable, can rotate, and practically this is going to enable us, well, to rotate or not. So here in the update function, we are going to check if we can rotate. So if can rotate, then we are going to rotate our, well, circle. And the last thing that we need is a private float, which is an angle. And practically now what we are going to do, and here I'm going to say this to be a wake function instead of, well, start function. And here I'm going to create void rotate the circle. So rotate the circle function. And this is going to be the function that's going to rotate our circle. And we are going to call it right here in our update function. So if we can rotate, then we are going to rotate the circle. And we are going to set can rotate to be equal to true here in the awake function. And here what we are simply going to do is we are going to take our angle, which is this one right here, and it's equal to transform dot rotation dot Euler angles dot z, because we only need to rotate the z angle. We don't need to rotate x and the y, because this is not a 3D game. And what we are going to do is we are going to say angle plus equals, and here we are going to use our rotation speed multiplied by time dot delta time. Now what this plus equals means, this right here that we wrote is equivalent to writing this. Angle is equal to angle plus rotation speed, so rotation speed multiplied by time, so time, so not time, let me just type it right, so time, again I have spelling problems, okay, time dot delta time finally. Okay, this right here that we wrote is the same as writing angle plus rotation multiplied by time dot delta time. And well, this time dot delta time is a really small number which denotes a time between each frame. So that small number it is. So if we have 60 frames per second, that's a really small number. And it's an interval by which the update function is called. So that's why we are using here this time dot delta time in order, well, to calculate our rotation speed. And next what we need to do is we need to simply say transform dot rotation. So rotation is equal to, or excuse me, rotation dot Euler angles is equal to quaternion dot Euler, and here we are going to pass a new vector 3. So here we need to say new vector 3, 0 for the x, 0 for the y, and angle, because this is our angle, we are passing angle for the z because we want to rotate our circle on the z axis. Now we can simply test this out. But before that, I made a mistake here and I just noticed it. We can remove this Euler angles. So transform dot rotation. This is going to access the transform of our circle, which is this one right here, and accessing the rotation. So here we have the rotation, and we are going to change that while using quaternion dot Euler and passing these values. So now if I run the game and we hit our circle, we see that nothing happens practically. But if we touch the circle, here we see that the circle is rotating on the z-axis. So we see that the z-axis is changing constantly. So what is the problem? Well, we need to go back here in our needle movement script. And here, when we touch our circle, we need to set our needle to be the child of the circle in order to move when its parent is moving. For that, we can say GameObject.transform.setParent, and here we can pass our target.transform to be the parent of our needle GameObject. Because if we go back here, we have the needle, and we see that the needle is a parent to the needle head and needle body, and when we move them, we see that both follow. Well, in order for our needle to rotate along with the circle, we need to make it its child. So when we hit the circle, we are going to do that through code using transform, set parent, and here passing the target, which is the circle, and its transform to be the parent of our needle. So now when I run the game, and now when we hit our, well, circle, we see that our needle is rotating. And notice here in the scene that now our needle is a child of the circle, so it's under the circle. And again, if I rerun it, here is the needle. It's here in the scene and not the child of the circle. If I run the game, we hit the circle and we see that our needle is now the child of the circle and they both are rotating. And here we have our rotation speed. So if I, well, rotate, so let's say at 200, we see that the speed is, well, very fast. If I set it to be negative, we see that it's rotating in another direction. So this is also beneficial for us in order to, well, manipulate our rotation here directly in the inspector panel.